in terms of elastic behaviour, you will have come across Hooke's law before. This is the idea that when you attach force to a spring, then what happens is, that's a long bell, when you apply force to a spring, what happens is you get an extension. Hooke's law tells us that force is proportional to that change in length. Okay, it's directly proportional. So it goes through the origin and you've got this straight gradient, flat gradient there of the same value. And Hooke's law applies up to the limit of proportionality. The limit of proportionality is the moment when directly proportional behaviour is not observed. So this would be the limit of proportionality here. Okay, the gradient of this line is your spring constant. Okay, so force divided by change in length equal to the spring constant. Okay, and that's also related to the stiffness. So the higher the value, the stiffer the spring would be. Spring constant is measured in newtons per metre. We also should know from GCSE that work done, also known as energy transfer, is force times by distance. We've got force, and a change in length is a distance, therefore the area under the graph is your elastic potential energy. Okay, so if we have a look at different materials, here we've got a material where we are applying a force and there is a change in length, and it's not exhibiting the same behaviour as that over there. So if we load it, that's adding forces, and then if we take the forces off, that is unloaded. Okay, due to the friction of the particles, that's why we've got a different shape. This is why in some degree level experiments they do an average of loading and unloading so they can account for that difference in friction. What you'll notice here is when it's unloaded, it's not returned to its original length. Okay, this area here represents permanent extension. Okay, which means that the object is permanently extended by this amount. Okay, this is also known as plastic deformation. It's the idea that the object has become deformed. Okay, if you are asked to figure out the heat loss, then that is the enclosed area here. Okay, and you can do that using area calculations or by counting squares. You do get marks for stating which method you have used. Thank you.